Hello there, and welcome to The Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the most misunderstood ideas in all of physics, a concept that quietly shapes everything around you, from the warmth of sunlight on your skin to the slow passing of time itself. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe. Only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a gentle joy to see all the places we gather from, each in our own little slice of time. Now, feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Imagine, for a moment, the sun, not as a distant ball of fire, but as something deeply familiar, something that touches your life every single day. The warmth on your face in the morning, the light filtering through a window, the gentle glow that tells your body it's time to wake up. If someone were to ask you a simple question, what do we receive from the sun? The answer might seem obvious. We receive light, we receive heat, we receive energy. And in a sense, that's true. Every second, an enormous stream of energy flows from the sun toward the earth. It travels across the vast emptiness of space, arriving here as sunlight, warming oceans, feeding forests, stirring the winds, and quietly sustaining life in countless unseen ways. But here's where things become a little more interesting. If you were to step back and look at Earth from far away, not as a place full of people and cities and movement, but simply as a physical system, you might ask a different question. If Earth is constantly receiving energy from the sun, what happens to that energy? Does it build up over time? Does it get used up? Does it somehow disappear? At first glance, it might feel like the Earth is holding on to that energy, storing it in the oceans, the land, the air, and perhaps even in us. But in reality, something much quieter and much more balanced is happening. Over long periods of time, the Earth sends almost exactly the same amount of energy back out into space as it receives from the sun. Not more, not less, almost exactly the same. If it didn't, the consequences would be impossible to ignore. If Earth kept more energy than it released, it would slowly heat up, becoming warmer and warmer over time. And if it released more energy than it received, it would gradually cool down, drifting toward a frozen stillness. But neither of these extremes is what we observe. Instead, the planet exists in a kind of delicate balance, receiving energy and then quietly letting it go. And so we arrive at a subtle, almost unsettling question. If the amount of energy coming in is roughly equal to the amount going out, then what is it that we're actually gaining from the sun? Because clearly, something is happening. Forests grow, clouds form, rivers flow, life continues. Something is changing, evolving, unfolding over time. And yet, if you only look at the total amount of energy, nothing seems to be increasing. It's like receiving money and spending exactly the same amount every day. The total in your account never changes, and yet somehow your life is full of activity. Things are being built, consumed, transformed. So where does that something come from? To begin to see it, it helps to look not at how much energy there is, but at how that energy is arranged. Imagine holding a small number of very bright, concentrated beams of light in your hands. Each one is intense, focused, almost like a spotlight. Now imagine that same amount of light spread out softly across an entire room, no longer sharp or concentrated but diffused, gentle, everywhere at once. The total light might be the same, but its usefulness, its character, has changed. In the first case, you could use it to illuminate a specific place, to create contrast, direction, purpose. In the second, it becomes something softer, less directed, harder, to gather and use in a focused way, and something very similar is happening with the energy we receive from the sun. The energy arrives in a more concentrated, more structured form, and then, over time, it leaves the Earth in a more spread out, more diffused way. Nothing is lost, but something has changed, something subtle but profound. It's as if the energy has quietly slipped from a state of order into a state of gentle dispersion. And this quiet transformation, this slow spreading, turns out to be one of the most important processes in the entire universe. It shapes the way heat flows. It determines why some things can happen and others almost never do. It even gives direction to time itself, separating what we call the past from what we experience as the future. But at this point in the story, we don't need to name it yet. It's enough to simply notice the pattern. That energy, when left to itself, tends to spread. It softens, it diffuses. It becomes harder to gather back together again, like a drop of ink slowly dissolving into water, or the warmth of a cup of tea gradually fading into the surrounding air. There is a quiet tendency in nature, a gentle leaning toward this kind of spreading. And once you begin to see it, you start to notice it everywhere, not as something dramatic or forceful, but as a soft, persistent background rhythm, a rhythm that carries everything forward, slowly, steadily, almost imperceptibly. And in the next part of our journey, we'll begin to trace where this idea first appeared, not in the vastness of space, but in something much more grounded, much more human, a simple machine, a question about heat, and a quiet realization that perfection in the physical world may never truly be possible. As that quiet question lingers, what is it that we're really receiving from the sun? It begins to feel like something just beneath the surface of what we usually notice. Not something hidden in a complicated equation, but something closer, almost familiar, like a detail you've always seen but never quite paused to think about. Because when we say that the Earth receives energy from the sun, we tend to imagine it as a single, simple thing. Energy, as if it were like water being poured into a container, a quantity, something you can measure, compare, and keep track of. And in many ways that's true, but what we often don't notice is that energy is not only about how much there is, but also about how it is arranged, and that quiet difference changes everything. Imagine for a moment that someone hands you a small stack of neatly wrapped packages. Each one is compact, carefully bundled and easy to carry. You can move them, store them, use them when you need them. There is a kind of structure to them, a sense of order. Now imagine that same amount of material, but instead of being bundled neatly, it has been scattered across a wide open field. The pieces are still there, nothing has been removed. The total is exactly the same, but now gathering it again would take time, effort, coordination. The difference is not in how much there is, but in how it is distributed. And this is very similar to what happens with the energy from the sun. The energy that arrives at Earth does not come in a soft, evenly spread glow. It comes in a more concentrated form, carried by light that is tightly packed, energetic and structured. You might think of it as arriving in small, intense bundles. When this energy reaches the surface of the Earth, something begins to happen. It is absorbed by the oceans, by the soil, by leaves reaching toward the sky. It warms the ground, stirs the air, sets things in motion, and in the process, it begins to spread out. Not suddenly, not dramatically, but slowly, quietly, almost imperceptibly. Over time, the same energy that arrived in a more concentrated form is released again, but now it is softer, more diffuse, less tightly held together. Instead of a few intense packets, it leaves as many gentler ones. It's a bit like taking a handful of ice cubes and leaving them on a table. At first, each cube is solid, clearly defined, easy to grasp. But as time passes, they melt, becoming water that spreads across the surface. Nothing has disappeared, but something has changed. The structure is gone. The energy is still there, but it is no longer in a form that can easily do the same kind of work. And this idea that energy can exist in more or less useful forms is one of the quiet keys to understanding the world around us. Because not all energy is equally capable of creating change. A tightly wound spring can lift a weight. A warm cup of tea can heat your hands. A beam of sunlight can power a leaf to grow. But once that energy has spread out, once it has softened and diffused, it becomes much harder to gather again into something structured. You can feel this in everyday life. If you walk into a room where someone has just sprayed perfume, the scent is strong and concentrated near the source. But give it a few minutes, and it spreads, filling the entire space. You can still smell it, but it's no longer something you can collect or focus in one place. Or think about a cup of coffee. When it's first poured, it's hot, full of energy that can flow into your hands, warming them. But as it sits, that warmth slowly fades into the surrounding air. The energy hasn't vanished. It has simply spread out, becoming part of the room itself. And once it has spread like that, it doesn't spontaneously gather back into the cup. It doesn't quietly return to being hot again. Not because it's forbidden, but because something about the way energy behaves makes that kind of reversal incredibly unlikely. There is a kind of gentle direction to these changes, not forced, not imposed from the outside, but emerging naturally, from the way things tend to move, and this is where the idea we are approaching begins to take shape more clearly. Because what we are really noticing is not just that energy moves, but that it tends to move in a particular way, from concentrated to spread out, from structured to diffuse, from something that can easily create change to something that quietly blends into its surroundings. And this tendency shows up everywhere. A drop of ink in water slowly dissolves. Warm air rises and mixes with cooler air. A tidy room, left alone, gradually becomes less tidy. Not because there is some force pushing things toward disorder, but because there are simply far more ways for things to be spread out than there are for them to stay neatly arranged. And so, without effort, without guidance, things drift in that direction. It's not a dramatic collapse into chaos. It's more like a soft unfolding, a gradual loosening, a quiet release. And this is why the question we began with, what we really receive from the sun, has such an unexpected answer. We are not just receiving energy. We are receiving energy in a form that has the ability to create structure, to drive motion, to sustain life. And in the process of using that energy, the Earth transforms it, releasing it again in a way that is more spread out, more gentle, less concentrated. Nothing is lost, but something becomes less available, less able to do what it once could. And this subtle difference between energy that is tightly held and energy that has been allowed to spread is the thread that will guide us deeper into the story. Because somewhere along the way, scientists began to notice this pattern, not just in sunlight or heat, but in machines, in matter, in the behaviour of the smallest particles. They began to ask, is there a way to describe this tendency, this quiet drift towards spreading? Is there a way to measure it, to understand it, to see how it shapes everything from a simple engine to the entire universe? And in searching for that answer, they uncovered a concept that would go on to redefine how we think about time, life, and the future itself. But before we give it a name, it helps to begin somewhere simple, not in the vastness of space, but in the steady rhythm of a machine, a piston moving up and down, heat flowing in and out, and a young mind wondering if perfection might be possible. As the idea of energy quietly spreading begins to take shape, it helps to step away from sunlight and drifting warmth for a moment and move into a different kind of scene, not a forest or a sky or a quiet room, but a workshop, a place filled with metal, motion, and purpose. Because long before anyone spoke about energy spreading out in abstract terms, there were people trying to solve a much more practical problem. How do you build a better machine? In the early 19th century, the world was beginning to change in ways that felt both exciting and uncertain. Steam engines were appearing across Europe, powering ships, lifting heavy loads from deep underground, and driving the first steps of what would become the industrial age. These machines transformed heat into motion. You could burn coal, heat water, create steam, and then use that steam to push a piston, turning wheels, moving objects, doing work. It was a remarkable idea, and yet there was a problem. Even the best engines of the time were surprisingly inefficient. A large amount of heat would go in, but only a small portion would become useful motion. The rest seemed to vanish into the surroundings, warming the air, the metal, the environment, without contributing to the work being done. It was as if something was quietly slipping away. And for a young man named Sadi Carnot, this was not just a technical inconvenience, it was a mystery. Carnot lived in a time shaped by political upheaval and rapid change. As the son of a military general with a deep interest in science, he grew up surrounded by both discipline and curiosity. He saw firsthand how technological strength could influence the fate of nations, and he began to wonder, if steam engines were so important, why were they so limited? Why couldn't we simply design a machine that converts all of its heat into motion? Why couldn't efficiency reach 100%? At first, this might seem like a straightforward engineering challenge. Improve the materials, reduce friction, seal the system more tightly, and perhaps eliminate all losses. But as Carnot looked more closely, something unexpected began to emerge. The problem was not just about imperfections in the machine. It seemed to be something deeper, something fundamental. To explore this, Carnot imagined a kind of ideal engine, not one made from real materials with all their imperfections, but a perfect version. A simplified system, free from friction, free from leaks, free from anything that might interfere. In his mind, he constructed a gentle cycle. You begin with a source of heat, something warm and full of energy. This heat flows into a chamber, causing the air inside to expand. As it expands, it pushes a piston, and that motion can be used to turn a wheel. Already you can picture it. A slow, steady push, a quiet transfer of warmth into movement. Then, as the cycle continues, the air is allowed to cool. It contracts, the piston moves back and the system resets, ready to begin again. In this idealized world, everything is smooth. Every movement is controlled. Nothing is lost to friction or noise. And most interestingly of all, the entire process could, in principle, be reversed. you could run the cycle backward. Instead of using heat to create motion, you could use motion to push heat back to where it came from. The system could return step by step to its original state, as if nothing had happened. It's a beautiful idea. A machine that leaves no trace. A process that can be undone completely. And yet, even in this perfectly imagined system, something subtle remains. Because when Carnot looked at how much useful motion the engine could produce, compared to how much heat it absorbed, he found that it still fell short of perfection. Even without friction, even without losses, it could never reach full efficiency. There was always a portion of heat that had to be released, not used, not converted into motion, but simply allowed to leave the system. And this raised a deeper question. If even a perfect machine cannot convert all heat into work, then what is limiting it? To begin to see the answer, it helps to imagine something simple. Picture a waterfall. Water at the top has potential. It can flow downward, turning a wheel as it goes. But once it reaches the bottom, that potential is gone. The water is still there, but it no longer has the same ability to do work unless it is lifted back up. In a similar way, heat behaves like a kind of flow. It moves from warmer places to cooler ones, and it is in that movement, that difference, that work can be done. If there is no difference, if everything is at the same temperature, then there is no flow, no motion, no work. So, for an engine to function, it must have two sides. A warmer side, where energy begins, and a cooler side, where some of that energy must end up. No matter how perfect the system is, some heat must always move to the cooler side, and once it does, it becomes harder to use. It has, in a sense, spread out. And this realization marked a quiet turning point, because it suggested that the limitations of engines were not just technical problems, but reflections of a deeper pattern in nature. A pattern where energy, once used, does not remain in its original concentrated form. It softens, it disperses, it becomes part of the surroundings, and while nothing is truly lost, something becomes less accessible, less capable of being gathered back into a focused, useful form. Carnot himself did not yet have a name for this idea. He described the behavior of heat, the role of temperature, the structure of the cycle, but the deeper meaning, the underlying principle, would only become clear later. Still, in his careful thinking, in his quiet observations, he had uncovered something essential, that even in a world of perfect machines, there are limits, not because of flaws, but because of the way nature itself unfolds. And as we move forward, this gentle constraint, this impossibility of perfect efficiency, will lead us closer to a concept that reshapes how we understand not only machines, but time, life, and the universe itself. For now, it's enough to hold on to that image, a machine turning heat into motion, a cycle that almost, but never quite, completes itself perfectly, and a small, inevitable drift, where some energy always slips away into the wider world. If you stay with that image for a moment, a quiet machine, moving in a smooth and steady rhythm, you can begin to see why it captured the imagination of thinkers like Sadi Carnot. There is something almost hypnotic about a system that repeats itself, a piston rising and falling, a wheel turning slowly, heat flowing in and then out again. It feels complete, as though everything is accounted for, as though nothing is wasted. And so, it's natural to wonder, if we imagine this machine perfectly, without friction, without leaks, without any imperfections at all, could it run forever, producing useful motion without ever losing anything? At first, it seems like it might, because in this ideal version, every step is carefully balanced. When heat flows into the system, it gently expands the air inside, pushing the piston upward. That motion turns a wheel, storing energy in a controlled, organized way. Then, as the system continues, the heat is released to a cooler place. The air contracts, the piston moves back down, and the cycle resets itself. And here's the remarkable part. If you were to run this process backward, every step would still make sense. The wheel could push the piston in reverse. The air would compress, warming slightly, and that warmth could be guided back into the hotter source. Step by step, the entire process could unwind, returning to its starting point. Nothing broken, nothing missing, nothing permanently changed. This idea is known as a reversible process, not because it happens naturally in reverse, but because in principle it could. It's like watching a perfectly choreographed dance. Every movement flows into the next, and if you were to play it backward, it would still look smooth, still make sense. And this is where the dream of a perfect engine feels closest. A system that leaves no trace. A process that can be undone. A cycle that could perhaps run endlessly. But as before, something subtle remains. Because even in this perfectly imagined world, the engine does not convert all of its heat into motion. Some of that heat must still be released, not because of flaws, not because of friction, but because of the structure of the cycle itself. To see why, imagine again that waterfall. Water begins at a higher level, full of potential. As it flows downward, it can turn a wheel, creating motion. But for the cycle to continue, the water must eventually reach a lower level. It cannot remain at the top forever. In the same way, heat flows from a warmer place to a cooler one, and it is in that flow, that difference, that motion becomes possible. If everything were at the same temperature, nothing would happen. No expansion, no contraction, no movement. So the engine depends on this difference, a warm side and a cool side. And in each cycle, some heat must travel from the warm side to the cool one. That heat is not turned into motion. It simply moves, and in moving, it becomes less available for doing work. Even though the total amount of energy remains the same, its ability to create change is reduced. And this leads to a quiet but powerful realization. The limitation of the engine is not about losing energy. It's about how that energy is distributed. When it is concentrated, held in a warmer place, it can drive motion, create change, do work. But as it spreads, as it moves into cooler regions, it becomes harder to gather, harder to use, harder to direct. It softens into the background, and once it has done so, the cycle cannot avoid leaving some of it behind. Now, there's a way to make the engine more efficient. You can increase the difference between the warm and cool sides, make the warm side hotter or the cool side colder. The greater the difference, the more potential there is for motion, for useful work. But even here, there are limits. To reach perfect efficiency, to convert every bit of heat into motion, you would need the cool side to be unimaginably cold, a state where all motion at the microscopic level comes to a complete standstill, a kind of absolute stillness. Or you would need the warm side to be infinitely hot, an endless source of energy beyond anything that exists in nature. Both of these are not just difficult, but impossible. And so, even in theory, perfection remains out of reach. Not because we lack the tools, not because we haven't tried hard enough, but because the universe itself is built in a way that gently resists it. And there's something quietly beautiful about that, because it suggests that the world is not a place where everything can be perfectly controlled, perfectly reversed, perfectly preserved. Instead, it is a place where processes unfold, where changes leave traces, where energy, once used, becomes part of something larger. You can begin to see this beyond machines. A warm room slowly cools when the window is open. A stretched spring eventually comes to rest. A moving object slows down as its energy spreads into the air and the ground. Again and again there is this same quiet pattern. Energy moves, and in moving it becomes less focused, less able to return to its original form. Even in systems that are designed to be as efficient as possible, there is always this gentle drift, a soft release into the surroundings, and once you begin to notice it, it becomes difficult to ignore, because it appears not just in engines, but in everything, in heat, in motion, in the way the world changes over time. And so the question begins to shift from, why can't we build a perfect machine, to something deeper. Why does energy tend to spread out at all? Why does it move from concentrated to dispersed, from structured to diffuse, from something powerful and directed into something soft and evenly shared? Somewhere within that question lies the key to a concept that will soon take shape, a concept that doesn't just describe machines, but describes the direction of change itself, a quiet measure of how energy moves, how it spreads, and how it slowly transforms the world around us. There is something quietly compelling about the idea of perfection, a machine that wastes nothing, a system that returns exactly to where it began, a process that leaves no trace behind. And for a moment, as we imagined that ideal engine moving in smooth, reversible cycles, it almost felt within reach. But as the details settled, a different picture began to emerge, not one of failure, but of limitation, not something broken, but something built into the fabric of how the world works. Because even in the most carefully imagined system, even in a machine untouched by friction, untouched by imperfections, something still slips away. Not energy itself, but its usefulness. And to understand why, it helps to pause and look at what we really mean when we say that energy is useful. Imagine holding a tightly coiled spring in your hands. It's full of potential. You can feel it, even before anything happens. If you release it, that stored energy can lift an object, turn a wheel, create motion in a clear and directed way. Now imagine that same amount of energy, not stored in a spring, but spread out as a gentle warmth in the air around you. The total energy is still there. Nothing has been removed. But now, there is no clear way to gather it back into something focused. It surrounds you, softly and evenly, but it doesn't lend itself to motion or work in the same way. The difference is not in how much energy there is, it's in how that energy is arranged. And this is the quiet constraint that Carnot uncovered. When heat flows through an engine, from a warmer place to a cooler one, it creates an opportunity for motion. That difference in temperature is like a slope, a gentle incline that energy can flow down, much like water flowing downhill. As long as there is a difference, there is potential. But each time the cycle completes, some of that energy ends up in the cooler place. It spreads out, becoming part of a larger, more uniform background. And once it has spread in this way, it is no longer easy to use. To continue the cycle, the system must accept this. It must allow some energy to move into a form that is less concentrated, less structured, less able to do work. And this is not a flaw. It is a requirement. Without releasing that energy, the system cannot reset itself. The piston cannot return. The cycle cannot begin again. It's as if the engine must pay a cost to keep running. And that cost is a small portion of energy becoming less useful with each cycle. Now you might wonder, could we reduce this cost? Could we design a system where less energy spreads out? And the answer is yes, to a point. By increasing the temperature difference between the warm and cool sides, you can improve efficiency. The greater the contrast, the more energy can be directed into motion before it begins to spread. But this improvement has limits. To eliminate the cost entirely to achieve perfect efficiency, you would need to prevent any energy from becoming dispersed, which would mean preventing any heat from reaching the cooler side. But without that transfer, there is no cycle, no movement, no reset, no continuation. The engine would simply stop. So, paradoxically, the very thing that allows the engine to run is also the thing that prevents it from being perfect. It must release energy in order to keep going. And this idea extends far beyond engines. You can see it in everyday life once you begin to look for it. Think of a ball rolling across the ground. At first it moves smoothly, carrying its energy forward, but gradually it slows down. Not because the energy has vanished, but because it has spread into tiny vibrations in the ground, into the air, into the countless microscopic interactions that surround it. The motion becomes less focused, less organized, until eventually as it comes to rest. Or consider a warm bath. At first, the water holds its heat, and you can feel it clearly. But over time, that warmth fades, not disappearing, but spreading into the surrounding air, into the walls, into everything around it. The energy becomes part of a larger, more even background, and once it has spread in this way, it does not gather itself back into warmth again, not on its own, not because it is impossible, but because the process would require a reversal of that spreading, a movement from a common, evenly shared state back into a rare, concentrated one, and such a reversal is extraordinarily unlikely. So unlikely that, for all practical purposes, it never happens. And this is the deeper realization that begins to take shape. The world does not simply conserve energy. It also transforms the way that energy is arranged, from concentrated to dispersed, from structured to diffuse, from something that can easily create motion to something that quietly blends into its surroundings. And once that transformation has occurred, it cannot be easily undone, not because of a barrier, but because of a tendency, a quiet leaning built into the way things unfold. And so, the dream of a perfect machine, a system that converts all energy into useful work without any loss, fades, not into failure, but into understanding. It was never about building a better engine. It was about discovering a deeper rule, a rule that does not forbid perfection outright, but gently steers everything away from it. A rule that explains why some processes can happen naturally, while others require effort, direction, and constant input to maintain. And as this understanding deepens, a new question begins to form. If energy naturally spreads out, if it moves from concentrated to diffuse, if this process shapes everything from machines to motion to warmth, is there a way to describe this tendency, to measure it, to give it a name? In the next part of our journey, we'll begin to see how this quiet pattern was finally captured, not as a vague idea, but as something that could be understood, described, and explored. A concept that would come to define not just how engines work, but how the universe itself evolves. There comes a moment, in any long train of thought, where something that has been quietly present all along finally takes on a name, not because it suddenly appears, but because you begin to recognize it. Up to now, we've been circling around an idea. We've seen it in sunlight arriving at the earth, in heat flowing through a machine, in warmth fading into the air, in motion slowly coming to rest. Again and again, the same pattern has appeared. Energy, when left to itself, tends to spread. It softens, it disperses, it becomes less concentrated, and less able to do the kind of focused work it once could. And for a long time, this was simply observed, noticed, described in pieces. Until, in the middle of the 19th century, a physicist named Rudolf Clausius decided to bring it all together. Clausius was studying the same kinds of systems that had fascinated Carnot: heat engines, temperature differences, the movement of energy between warm and cool places. But instead of focusing only on how much work could be done, he asked a quieter, deeper question. What happens to energy as it moves? Not just where it goes, but how its character changes. To capture this, he introduced a new idea, a way of measuring not the amount of energy, but how spread out that energy had become. He called this quantity entropy. Now, at first, the word itself can feel a little distant, abstract, almost like something that belongs only in textbooks. But the idea behind it is something you've already felt. Entropy is not about how much energy there is. It's about how that energy is arranged. When energy is concentrated, held in a warm object or a tight structure, it is in a state of lower entropy. It is focused, organized, capable of creating change in a clear direction. As energy spreads out, moving into the air, the surroundings, the wider environment, it enters a state of higher entropy. It becomes more evenly distributed, less structured, less able to be gathered back into something useful. Nothing is lost, but something has shifted. And entropy is a way of describing that shift. You can think of it like this. Imagine a drop of ink placed gently into a glass of water. At first, the ink is clearly defined, a small, dark shape against a clear background. But slowly, almost beautifully, it begins to spread. Thin strands reach outward, swirls form. The colour softens, expands, dissolves into the surrounding water. Eventually, the entire glass becomes a uniform shade. The ink is still there, every bit of it, but it is no longer concentrated in one place. It has spread, and in doing so, it has become much harder to gather again. That final, evenly mixed state is a state of higher entropy, and the initial concentrated drop is a state of lower entropy. The process itself, the gentle spreading, that is the increase of entropy. Clausius saw that this wasn't just a property of ink and water, or heat and machines. It was something universal. So he summarized his understanding in two simple ideas. First, that the total amount of energy in the universe remains constant. Energy can change form, move from place to place, but it is never created or destroyed. And second, that as time passes, entropy tends to increase. In other words, energy spreads out. Not suddenly, not violently, but gradually, steadily, inevitably. Now, it's important to notice something subtle here. Entropy does not say that everything becomes chaotic or disordered in a dramatic sense. It doesn't mean that the world falls apart, it simply means that energy becomes more evenly distributed, more spread out, less concentrated in specific places. And this distinction matters. Because when we hear the word disorder, it can feel negative, almost emotional. But entropy is not about disorder in that sense. It is about probability, about how many ways energy can be arranged. There are very few ways for energy to be concentrated in one place, but there are many, many more ways for it to be spread out. And so, without any guiding force and without any intention, systems naturally move in that direction, not because they are being pushed, but because there are simply more possibilities waiting there. This is why a hot object cools, why a scent fills a room, why motion slows and warmth fades. Not because something is forcing it to happen, but because it is overwhelmingly more likely, and once it has happened, reversing it would require all those tiny pieces to come back together in just the right way, a possibility so rare that it effectively never occurs. And so entropy quietly gives direction to change, not by imposing a rule, but by shaping what is likely and what is not. It tells us that while energy remains, its ability to create structured, directed motion slowly diminishes, that the world moves, gently but persistently, from states of concentration towards states of dispersion. And yet, within this process, something remarkable happens, because it is precisely this movement, this flow from low entropy to higher entropy, that allows anything to happen at all. Without it, there would be no motion, no change, no life, just a still, unchanging balance. So entropy is not simply a story of loss, it is also a story of possibility, a quiet measure of how energy moves, and how, in moving, it shapes the unfolding of everything we experience. And as we continue, we'll begin to see that this idea, simple as it may seem, reaches far beyond heat and machines. It extends into the realm of chance, of probability, and into the very question of why time seems to flow in only one direction. Now that the idea of entropy has begun to take shape, something almost magical happens. What once felt like separate observations, heat fading, motion slowing, energy spreading, begins to come together into a single, quiet pattern. Not a force, not a command, but a tendency, a direction that things seem to follow without being told. And this is where Clausius's insight becomes something more than just a definition. It becomes a law, not a law in the sense of something enforced, but in the sense of something that is always gently true. He described it in a simple way. The total amount of energy remains constant, but the way that energy is arranged becomes more spread out over time. Or more softly put, energy stays, but it becomes less concentrated, less gathered, less able to create focused change. This idea is known as the second law of thermodynamics, though the name itself matters far less than what it describes. Because once you begin to notice it, you start to see it everywhere, not as something dramatic, but as a quiet background rhythm. A cup of tea left on a table gradually cools, not suddenly but slowly, releasing its warmth into the surrounding air. A drop of perfume once released fills a room, not by force, but by spreading, gently reaching every corner. A piece of ice, placed in a glass, melts into water. The solid structure softens, becoming fluid, blending with its surroundings. Each of these is a simple, familiar moment, and yet they all follow the same pattern. Energy moves from where it is concentrated to where it is less so, from warmer to cooler, from focused to diffuse, from structured to evenly spread. And once it has moved in that way, it does not return on its own. The tea does not reheat itself. The perfume does not gather back into the bottle. The melted ice does not quietly reassemble into its original shape. Not because it is impossible, but because it is overwhelmingly unlikely. There is something deeply calming in this realization, because it means the world is not unpredictable chaos, but neither is it rigidly controlled. Instead, it moves with a kind of gentle preference, a leaning toward what is more probable, more evenly distributed, more shared. And this leaning is what gives rise to something we experience every day, but rarely question. The feeling that time moves forward. Think about it for a moment. You remember yesterday. You remember moments from earlier today. But you do not remember tomorrow. You cannot recall events that have not yet happened. This might seem obvious, almost too simple to question. But from the perspective of the laws of physics, it is actually quite strange, because many of the fundamental rules that describe motion, forces, and interactions work just as well forward as they do backward. If you were to watch a video of two objects colliding and then play it in reverse, the motion would still look possible. Nothing in those basic interactions seems to prefer one direction over the other, and yet, in everyday life, we clearly see a direction. Things change, they age, they unfold, they move from one state into another and not the other way around. And the reason for this, quietly, is entropy, because the increase of entropy defines direction. It tells us that systems naturally move from less probable states to more probable ones, from concentrated arrangements to spread out ones, from special ordered conditions to more common, evenly distributed ones. And that movement, from unlikely to likely, is what we experience as the passage of time. It is not that time itself is pushing things forward. It is that the arrangement of energy is changing in a way that has a clear direction. And we, living within that change, feel it as time. You can think of it like a story written in sand. At the beginning, the shapes are clear, distinct, carefully formed. But as the wind passes over them, they soften, blur, and eventually fade into a smooth surface. There's a direction to that process, a beginning and an end. And once it has happened, it does not spontaneously reverse. The wind does not gather the grains back into their original patterns. Not because it cannot, but because there are far more ways for the sand to be smooth than there are for it to form that specific pattern again. And so, gently, inevitably, it moves forward. This is the quiet power of the second law. It does not act like a force. It does not push or pull. It simply describes what is overwhelmingly likely to happen, given enough time. And because it applies to everything, from the smallest particles to the larger structures, it becomes one of the most universal patterns in all of physics. It shapes the cooling of stars, the movement of air in the atmosphere, the flow of heat through your body, the unfolding of every moment you experience. And yet it does all of this without urgency, without drama, just a steady, patient drift toward a more evenly shared state. But within that drift, something remarkable takes place. Because while entropy increases overall, there are moments, places, and systems where energy becomes temporarily concentrated again, where structure forms, where complexity appears, where life emerges, not in opposition to this law, but within it. And that is where our story begins to deepen, because understanding how entropy increases is only part of the picture. The more subtle question, the one that leads us further still, is this: why does this tendency exist at all? Why is it that there are so many more ways for energy to be spread out than to be held together? To answer that, we need to look deeper, not at heat or motion, but at the hidden world beneath them, a world of tiny possibilities, countless arrangements, and a quiet mathematics of chance. There is a quiet shift that happens once you begin to look beneath the surface of things. Up until now, we've spoken about energy spreading, about warmth fading, about motion softening into stillness, and it might feel as if something in the world is slowly falling apart, as if there is a kind of hidden force gently pushing everything toward disorder. But this is where the story becomes even more subtle, because nothing is actually pushing things toward disorder. There is no invisible hand, no force that prefers chaos over order. Instead, what we are seeing is something much quieter, something rooted not in force, but in possibility. To begin to see it, imagine something very simple. A tidy room, everything is in its place. Books are neatly stacked, clothes are folded, the floor is clear, it feels calm, structured, intentional. Now imagine leaving that room untouched for a long time. No one enters, nothing is actively disturbed, but over days or weeks, small changes begin to appear. Dust settles on surfaces. A book shifts slightly. A breeze from an open window nudges something out of alignment. And gradually, the room becomes less tidy, not dramatically, not all at once, but slowly, quietly. It drifts away from that perfect arrangement. Now, here's the important question. Why? Why is it so easy for a room to become messy, but so unlikely for a messy room to become perfectly tidy on its own? The answer is not that messiness is preferred. The answer is that there are simply more ways for the room to be messy than to be perfectly arranged. There is only one way, or a very small number of ways, for everything to be exactly in its place. But there are countless ways for things to be slightly out of place. A book tilted instead of straight, a shirt folded imperfectly, a chair moved just a little from where it started. Each of these is a different possibility, and when you consider all of them together, the number of messy arrangements becomes enormous. So even if nothing is actively trying to create disorder, the system naturally drifts toward the states that are most common, not because they are better, but because they are overwhelmingly more likely. And this idea lies at the heart of entropy. It is not about disorder in the emotional sense. It is about counting possibilities. Physicists describe this by thinking about all the tiny ways a system can be arranged, while still looking the same from the outside. For example, imagine a box filled with air. To your eyes, it looks uniform, the same everywhere. But at a deeper level, each molecule is moving, bouncing, shifting in its own path. There are countless ways for those molecules to be arranged, while still creating the same smooth, even appearance. Now imagine trying to gather all those molecules into one corner of the box. It's not impossible. There is nothing in the laws of motion that forbids it. But the number of ways for all the molecules to be evenly spread is vastly greater than the number of ways for them to all be clustered in one place. So, naturally, the system remains spread out, not because it must, but because it almost always will. And this is the deeper meaning behind entropy increasing. It is not that systems are being pushed toward disorder, it is that they are exploring all the possible ways they can exist, and most of those ways correspond to energy being spread out. You can think of it like wandering through a vast landscape. There are only a few narrow paths that lead to very specific ordered arrangements, but there are wide open plains where countless different configurations are possible. If you walk randomly, without choosing a direction, you will almost always end up on the open plains, not because you were guided there, but because they take up so much more space. And this brings us to an idea that feels almost surprising. Some things we think of as impossible are not truly impossible at all. They're just incredibly unlikely. For example, imagine a cold object sitting next to a warm one. We know that heat flows from warm to cold. The warmer object cools down, and the cooler one warms up. But in principle, the reverse could happen. The colder object could spontaneously become colder, while the warmer one becomes even warmer. Energy could flow the wrong way. Nothing in the basic rules of motion strictly forbids it. But for that to happen, all the tiny particles involved would need to move in just the right way, all at once, aligning perfectly to reverse the natural flow. And the probability of that happening is so small that it effectively never occurs. It is not impossible. It is simply beyond unlikely. And so, what we call the direction of processes in the world is really a reflection of probability. things move from less likely states to more likely ones, from rare arrangements to common ones, from tightly structured configurations to more freely spread ones. And once you see it this way, the world feels a little different, not chaotic, not random in a careless sense, but gently guided by the quiet mathematics of possibility, a mathematics that does not force outcomes, but shapes what is most likely to happen. And this is why things fall apart so easily, not because they are being torn apart, but because there are so many more ways for them to exist in a slightly less ordered state. A stack of papers can become uneven in countless ways, but there are very few ways for it to remain perfectly aligned. A deck of cards can be shuffled into an enormous number of mixed arrangements, but only one of those is the perfectly ordered sequence it began with. And so, without intention, without effort, systems drift, gently, persistently, toward the states that are easiest to reach, the states that are most numerous, the states that require the least coordination. And this is where entropy reveals its deepest nature, not as a force, not as a measure of disorder, but as a reflection of how many ways the world can be arranged. And as we move forward, we'll begin to see how this simple idea, this quiet counting of possibilities, gives rise to something even more profound, the sense that time itself has a direction. There is a quiet comfort in believing that some things simply cannot happen, that a broken glass will not reassemble itself, that a cooled cup of tea will not suddenly grow warm again, that the air in a room will not gather into one corner, leaving the rest empty. We move through the world with these expectations so naturally that they feel like rules, unbreakable, absolute. And yet, when we look more closely, something subtle begins to shift, because the laws that govern motion at the smallest scales do not forbid these things. They do not say, this must never happen. Instead, they allow for every possible movement, every possible interaction, every possible arrangement, which means that, in principle, even the most unlikely events are still allowed. And this is where the idea of entropy becomes both clearer and more surprising, because what we call impossible is often not impossible at all. It is simply unimaginably unlikely. To feel this more deeply, imagine something simple, a deck of cards. When it is new, it arrives in a perfectly ordered sequence. Every card is in its place, arranged in a precise and deliberate pattern. Now imagine shuffling it. Each shuffle rearranges the cards in a new way. After just a few shuffles, the deck looks completely random. And here's the quiet truth. There is only one way for the deck to be in that original, perfectly ordered state. But there are more possible shuffled arrangements than there are grains of sand on all the beaches of the earth, an unimaginable number of possibilities. So when you shuffle the deck, you're not creating disorder. You're simply moving from one very rare arrangement into one of the countless common ones. And once you're there, the chance of returning to that original order by random shuffling alone becomes so small that it effectively never happens, not because it is forbidden, but because the number of possible alternatives is overwhelming. Now bring that idea back to something physical. Imagine a box filled with gas. At any moment, each tiny particle is moving, colliding, changing direction. There is nothing preventing all of those particles from drifting into one corner of the box, leaving the rest empty. Nothing in the fundamental rules says, this is not allowed. But for that to happen, every single particle would need to move in just the right way, at just the right time, coordinating perfectly without any guiding force. The number of ways for the particles to be spread evenly is so vast, compared to the number of ways for them to cluster, that the clustering becomes almost impossible to observe. It could happen, but it almost certainly will not, and this is the illusion. We see events that never happen, and we assume they are impossible, but in reality, they're just hidden beneath layers of overwhelming probability. And once you begin to see this, the world feels slightly different, less rigid, less absolute, and more like a landscape of possibilities, where some paths are so wide and open that everything naturally flows into them, while others are so narrow, so specific, that they are almost never found. This is why a broken glass does not reassemble itself, not because the pieces cannot move back into place, but because there are so many more ways for them to remain scattered. Each tiny fragment would need to move in perfect harmony, reversing every collision, every vibration, every interaction that caused the break. The likelihood of that happening is so small that for all practical purposes it is zero. And yet, it is not truly zero. It is just unimaginably close. This idea extends even further. Think again of heat flowing between two objects. A warm object cools, a cool object warms, until they reach the same temperature. But at the microscopic level, energy is constantly moving back and forth. Tiny packets of motion shift between particles in all directions, and occasionally, just by chance, a small amount of energy might flow from the cooler region back into the warmer one. For a brief moment, a tiny reversal occurs, but these small reversals are quickly overwhelmed by the far more common movements in the opposite direction. So the overall pattern, the one we observe, is always heat flowing from warm to cool, not because the reverse is forbidden, but because it is drowned out by probability. And this is what gives rise to the sense that processes have a direction, that some things naturally happen while others do not. In truth, all possibilities exist, but some are so rare that they remain hidden from experience. And so, we build our understanding of the world around what we see. We say, heat flows from hot to cold, objects slow down, things fall apart. But beneath those observations, there is a deeper layer, a quiet statistical truth, that the universe is constantly exploring all possible arrangements, and that the ones we observe are simply the ones that happen most often. And this brings us to a gentle but profound realization. The direction we perceive in the world is not imposed from above. It is not written into the laws as a strict command. It emerges from the balance of possibilities, from the simple fact that some states are vastly more numerous than others, and so, without intention, without guidance, the world drifts toward them, like a river finding the widest path through a landscape, or a drop of dye spreading through water until it becomes invisible. And within that drift, we find something deeply familiar, a sense of unfolding, a sense that moments move forward, that changes accumulate, that the past and future are not the same. And in the next step of our journey, we will begin to see how this quiet imbalance of possibilities, this gentle preference for what is more likely, becomes the very foundation of time itself. There is something quietly reassuring about patterns, not the rigid kind, not the kind that demands precision, but the gentle kind, the kind that reveals itself slowly as you begin to notice the same idea appearing again and again, in different forms, in different places, across different scales. And by now that pattern is beginning to feel familiar. Energy spreads, structures soften, arrangements drift from rare into common, not because they are forced to, but because there are simply more ways for them to be that way. And once you begin to see the world through this lens, everything starts to feel a little more connected, a little more understandable. Not because every detail becomes simple, but because there is a quiet principle underneath it all. A principle that says, given enough time, systems tend to move toward what is most likely, not what is best, not what is most beautiful, but what is most common. To feel this more clearly, imagine holding a perfectly solved puzzle. Every piece is in exactly the right place. The image is complete. The structure is precise. Now, imagine gently shaking the table. Just a little. A few pieces shift. The edges blur. The perfect arrangement begins to loosen. Shake it again and again. And over time, the puzzle becomes a scattered collection of pieces. Now ask yourself, how many ways are there for the puzzle to be perfectly solved? Just one. And how many ways are there for it to be partially or completely mixed? Almost countless. So each tiny movement, each slight disturbance, nudges the system away from that single, rare arrangement and into the vast landscape of more common ones. No intention, no force, just probability. And this is how the world quietly evolves, not through dramatic shifts, but through countless small steps, each one moving slightly toward what is easier to achieve, what requires less coordination, what allows more freedom. You can see this in something as simple as a drop of cream swirling into a cup of coffee. At first, the cream enters as a distinct shape, curling, folding, creating beautiful patterns as it mixes. For a brief moment, there is complexity, structure, motion that feels almost alive. But then, gradually, the patterns fade, the colours blend, and the entire cup becomes a uniform shade. Not because the beauty was destroyed, but because it was temporary, a momentary arrangement, caught between two extremes. And this reveals something subtle. Low entropy, where everything is perfectly ordered, is simple. High entropy, where everything is completely mixed, is also simple. But in between, there is a window, a narrow range of possibilities where complexity can exist, where patterns form, where structures appear, where life itself becomes possible. And this window is not permanent. It exists only because the system is moving from less likely states to more likely ones. It is a moment in the flow, a brief pause between extremes, and within that pause, everything we recognize as interesting, as meaningful, as alive, takes shape. This is why the world feels dynamic, why things change, why patterns emerge and then fade, because the system is always moving, always exploring, always drifting toward the states that are easiest to reach. Now, imagine this process happening, not just in a cup of coffee or a scattered puzzle, but everywhere, in the air around you, in the warmth of your body, in the motion of planets, and the light of distant stars. At every level, the same quiet rule applies. The world favours the likely, not because it must, but because given all the possibilities, that is where it almost always ends up. And this leads us to a realization that feels both simple and profound. What we experience as the natural behaviour of things is not a set of strict commands. It is a reflection of probability, a reflection of how many ways the world can arrange itself. And once you begin to see this, the idea of direction, of change, of time itself, begins to take on a new meaning. Because what we call moving forward is really just moving toward more likely states, from tightly arranged to loosely spread, from rare configurations to common ones. And this movement, this gentle drift through possibility, gives rise to something deeply familiar, the sense that the past is different from the future, that things unfold in one direction and not the other. But at this point, we are only beginning to glimpse it, because to truly understand why time feels the way it does, we need to take one more step to see how this quiet preference for the likely shapes not just what happens, but when it happens. There is a quiet mystery that follows you everywhere, so familiar that it rarely feels like a mystery at all. Time. It moves forward, always forward, from morning into evening, from yesterday into today, from memory into anticipation. You feel it in the rhythm of your life, in the way moments unfold one after another, never quite returning to where they began. But if you pause and look closely, something curious appears, because when physicists write down the fundamental rules that describe motion, how objects move, how particles interact, how forces act, those rules do not seem to prefer a direction. They work just as well if time moves forward as if it moves backward. If you were to watch a simple motion, say a ball rolling across a smooth surface, and then play that motion in reverse, nothing would look out of place. The ball could just as easily be speeding up as slowing down. The equations in their quiet neutrality do not object, and yet, in the world you experience there is a clear difference. A cup falls and shatters, but the pieces do not rise and reassemble themselves into a perfect whole. A drop of ink spreads through water, but it does not gather itself back into a single dark point. A warm room cools, but it does not on its own become warm again. There is a direction to these processes, a sense of before and after, and that direction does not come from the basic laws of motion. It comes from entropy, from the quiet tendency we have been tracing, the movement from less likely states to more likely ones. To feel this more deeply, imagine capturing a moment in time, a very specific arrangement of the world, a glass standing intact on a table, a pattern of molecules held in a delicate balance, a structure that, while stable, is also very specific. There are only a limited number of ways for that exact arrangement to exist. Now, imagine what happens when the glass falls. It shatters into many pieces. Each fragment moves, collides, settles into a new position. The number of possible arrangements of those scattered pieces is enormous. There are countless ways for the glass to be broken, but only a few ways for it to be perfectly whole. And so, when the glass breaks, it moves from a rare state into a much more common one, from unlikely to likely. And that movement is what gives us the sense that time has passed. Because if you were to reverse the process, if you were to see the pieces of glass leap up from the floor and assemble themselves back into a perfect shape, you would immediately recognize something as being wrong. Not because the motion is forbidden, but because it moves from a common state into a rare one. It goes against the quiet flow of probability. And this is the essence of what physicists call the arrow of time. Not a physical arrow, not a force pushing things forward, but a direction defined by entropy increasing, by systems moving from less probable arrangements to more probable ones. And once you begin to see it this way, time becomes something different. Not a thing that flows, but a way of describing change, a way of tracking how the arrangement of energy evolves, how it spreads, how it explores the vast landscape of possibilities. You can think of it like walking through a landscape at night. Behind you are the narrow paths you've already taken. Ahead of you are countless open directions branching outward. Each step you take carries you further into that open space, into the realm of what is possible. And as you move, you leave behind the more specific, more constrained paths that led you there. This is why the past feels fixed and the future feels open. The past corresponds to states of lower entropy. more specific, more structured. The future corresponds to states of higher entropy, more numerous, more possible. And you, moving through this unfolding, experience that transition as time. It is not the time itself is pushing you forward. It is that the universe is evolving from rare arrangements into common ones, and you are part of that process. You are carried along with it. And this also explains something deeply personal, why you remember the past, but not the future. Memory is a record of structure. It depends on the existence of organized states, patterns that can be stored, preserved, recalled, and those organized states belong to lower entropy. As entropy increases, those patterns fade, soften, become harder to distinguish, so your memories point backward toward the more structured past, while the future, not yet arranged, remains open, undefined, and so, quietly, without announcing itself, entropy shapes your experience of time. It tells you which way is forward and which way is not. It gives meaning to change, to aging, to the unfolding of events, and yet at its core, it is simply a matter of probability, a reflection of how many ways the world can be arranged. There is something almost poetic in this, that the flow of time, something we feel so deeply, so continuously, emerges not from a force, not from a rule imposed from above, but from the simple fact that there are more ways for things to be spread out than to be held together, and so, gently, inevitably, the world moves in that direction, and we move with it. There is something quietly intimate about time, not just the way it moves in the world around you, but the way it moves within you. You feel it in memory, in the soft weight of moments that have already passed, in the clarity of things you can recall, even if only faintly, a conversation, a place, a feeling that lingers just at the edge of thought. And yet, when you turn your attention forward, toward what has not yet happened, there is nothing to remember, only possibility, only a kind of open space waiting to be filled. This difference feels so natural, so deeply embedded in experience that it rarely seems worth questioning. Of course we remember the past, of course we don't remember the future, but as with so many things in this journey, when you look more closely, the simplicity begins to unfold into something deeper, because memory itself depends on structure. To remember something, there must be a pattern, a configuration of matter within your brain that holds information about what has occurred, tiny connections arranged in a particular way, storing traces of sound, sight, feeling. And these arrangements, these structured states, are not random, they are specific. They correspond to lower entropy, to configurations that are more ordered, more defined. Now imagine what would happen if those structures were to dissolve completely, if every connection became indistinguishable, if every pattern blurred into a uniform background. There would be no memory, no distinction between one moment and another, no sense of continuity. And this is why memory points backward, because the past is where these structured states exist. It is where arrangements were more specific, more constrained, more defined. As entropy increases, those structures begin to soften, not all at once, not completely, but gradually. Memories fade, details blur, edges soften, and while new structures are constantly being formed, new memories, new patterns, they too are part of the same process. They're created by using concentrated energy, and in doing so, they contribute to the overall spreading of energy in the system. Even the act of remembering, of thinking, of forming identity is part of this quiet flow. It draws on structured energy and releases it in a more diffuse form. And so, in a very real sense, your experience of time, your awareness of past and future, is woven into the same process that governs heat, motion, and the unfolding of the universe. There is no separate mechanism, no special exception, just the same gentle tendency, expressed in a different way. Now consider something even more subtle. Why does the future feel open? Why does it seem like a space of possibility, while the past feels fixed, already determined? The answer lies, once again, in the number of possible arrangements. The past corresponds to a specific path, a sequence of events that has already unfolded. There are only a limited number of ways for those exact events to have occurred. But the future has not yet taken shape. It represents all the possible ways the system could evolve, all the configurations that have not yet been realized. And because entropy tends to increase, the number of accessible future states is vast. Each moment opens into many possibilities. Each choice, each interaction, each tiny fluctuation branches into new arrangements. And so, the future feels wide, uncertain, open, full of paths that have not yet been taken, while the past feels narrow, defined, fixed, a single thread through an immense landscape of alternatives. And this difference is not just philosophical. It is grounded in the same quiet mathematics of probability we've been exploring. It is a reflection of how systems move through states, how they evolve from rare configurations into more common ones, and as they do, the number of possible future paths increases. The landscape expands. Now imagine a world where entropy does not increase, where energy does not spread, where structures do not soften, where arrangements do not drift toward more probable states. In such a world, there would be no clear distinction between past and future. Processes could unfold in either direction with equal likelihood. A broken glass might reassemble just as easily as it shatters. Heat might flow from cold to warm, as often as from warm to cold. Memory, if it existed at all, would not point in a single direction. It would not anchor experience. There would be no sense of before and after in the way we understand them. Just a kind of timeless equilibrium, a stillness, where change has no preferred path. And in that stillness, something essential would be missing. Because it is the increase of entropy, the unfolding from less likely to more likely states, that creates the conditions for experience itself, for memory, for identity, for the sense of moving through time. And so, while entropy is often described as something that leads to loss, to fading, to the eventual quieting of all activity, it is also the very reason anything can happen at all. It is what allows the world to change, what allows patterns to form and dissolve and form again, what allows you to sit here in this moment, aware of what has been and curious about what might come next. There is something gently humbling in this, that the flow of time, something so central to your experience, arises from a simple, quiet principle, that energy spreads, that possibilities unfold, that the world moves, not by force, but by the balance of what is most likely. And as we continue, we'll begin to see how this same principle, which shapes your thoughts and memories, also gives rise to something far larger, the emergence of life itself. There is a moment as you begin to understand entropy, when something feels slightly off, a quiet contradiction. Because everywhere we've looked, the same pattern has appeared. Energy spreads, structures soften, things drift from concentrated into dispersed. And yet, here you are, a living system, highly organized, structured, complex in ways that seem almost impossibly delicate. Your body maintains its shape. Your cells carry intricate patterns. Your thoughts emerge from a network of connections more detailed than anything we have ever built. And the same is true for all life around you. A tree grows upward from the soil, forming branches, leaves, and intricate internal systems. An animal moves with purpose, its body maintaining balance, temperature, and form. Even the simplest organisms carry within them a kind of order, a structure that persists over time. At first glance, this seems to go against everything we've been exploring. If entropy always increases, if energy tends to spread out, then how can something like life exist? How can order arise and be sustained in a universe that gently leans toward dispersion? It's a beautiful question, and the answer begins with a simple realization. Life does create order, but not everywhere, only locally. To see what this means, imagine building something with your hands. Perhaps you are arranging stones into a small structure. Each stone is placed carefully, one at a time, forming something stable, something intentional. From your perspective, you are creating order. But in the process, your body is working. You're using energy. Your muscles are moving. Your body is releasing heat into the surrounding air. And that heat, that subtle warmth, is spreading outward. So while the stones become more ordered, the environment around you becomes slightly more disordered, more diffuse, more spread out. And if you consider both together, the structure you built and the heat released, you find that the total entropy has still increased. The local decrease in entropy, the creation of order, is more than balanced by a greater increase elsewhere. And this is the key. Life does not break the rule. It works within it. Every living system takes in energy in a more concentrated form and releases it in a more spread out form. You can see this in something as simple as eating. Food contains energy that has been stored in a structured way, organized, concentrated, ready to be used. When you eat, your body breaks that structure down. Some of that energy is used to maintain your body, to build and repair cells, to support the patterns that define you, but much of it is released as heat, as movement, as waste products that disperse into the environment. So while your body maintains its internal order, the world around you becomes slightly more disordered. Energy spreads, entropy increases. The same is true for plants. They absorb light from the sun, energy that arrives in a concentrated, structured form. Using that energy, they build sugars, tissues, and complex biological structures. But in doing so, they also release energy back into the environment. Heat flows outward. Chemical processes spread energy in many directions, and once again, the total entropy increases. Life, then, is not an exception to the rule. It is a participant in it, a system that uses the flow of energy, from concentrated to dispersed, to create temporary pockets of order. And these pockets, while remarkable, are not permanent. They exist only as long as energy continues to flow through them. If that flow stops, if the system is cut off from its source of concentrated energy, the structures begin to fade. Gradually, gently, they return to the same pattern we've seen everywhere else. Order softens, structure dissolves, energy spreads. You can see this in the simplest way. A plant without sunlight begins to wither. An organism without food loses its ability to maintain its internal balance. Without a constant input of energy, life cannot hold its shape. And this reveals something quietly profound. Life is not a fixed state. It is a process, a continuous balancing act, sustained by the flow of energy through the system. And in that process, entropy is always increasing, not in spite of life, but because of it. There is something almost poetic in this, that the very thing that seems to resist entropy is actually woven into its fabric, that the structures we admire, the complexity we observe, arise not by opposing the natural tendency of the universe, but by channeling it, guiding it, using the flow of energy to create moments of organization before it continues on its way. And this is why life feels so dynamic, so alive, because it exists in that narrow space between extremes, between complete order and complete dispersion, between structure and softness, a fleeting balance, sustained for a time by the constant movement of energy. And as we continue, we'll begin to see something even more surprising, that life does not just exist within this flow, it may in fact be one of the most effective ways the universe has found to carry it forward. There is a quiet shift that happens when a paradox begins to resolve. At first, life seemed like an exception, a kind of delicate rebellion against the steady spreading of energy, something that gathers order, builds structure, holds complexity together in a universe that gently leans the other way. But now, as we look more closely, that idea begins to soften, because life does not stand apart from this process. It moves with it, and in a deeper sense, it may even enhance it. To see how, it helps to return to something simple. Energy, when it is concentrated, has the ability to create change. But when it is spread out, that ability fades. So if the universe naturally moves towards spreading energy, then any process that helps energy spread more efficiently is, in a sense, aligned with that direction. Now imagine a place where energy is constantly flowing in, not randomly, but in a steady stream, a continuous arrival of concentrated energy, like sunlight reaching the surface of the earth. At first, that energy might simply warm the ground, slowly dispersing into the air, but under the right conditions, something more interesting can happen. Structures can begin to form, not because they are trying to resist the flow, but because they provide new pathways for it. A leaf, for example, does not stop sunlight from spreading. It absorbs it, transforms it, and in doing so releases energy in new forms, heat, chemical changes, interactions that ripple outward, and in the process, the total spreading of energy increases. More pathways open, more interactions occur, more energy is dispersed into the surroundings. In this way, the structure is not a barrier, it is a channel, a way for the flow to continue, perhaps even more effectively than before. And this idea leads to a surprising perspective, that life itself may be understood as a kind of system that helps energy spread, not by passively allowing it, but by actively transforming it, taking in concentrated energy and releasing it in more distributed forms. You can see this clearly in your own body. Every moment you take in energy, through food, through oxygen, through the subtle exchanges that keep your cells alive. That energy arrives in a structured form, but once inside, it is used to maintain your body, to support movement, to sustain thought, and in doing so, it is released as warmth, radiating gently from your skin, as motion, interacting with the world around you, as countless tiny processes, each contributing to the spreading of energy. Even at rest, your body is quietly dissipating energy into the environment, and the same is true for all living systems, from the smallest organisms to the largest ecosystems. Life takes in concentrated energy and releases it in more diffuse forms, and because of this, life can be seen not as something that slows entropy, but as something that accelerates it, a way for the universe to move more efficiently toward more probable states. This idea has been explored by scientists who study how systems behave when energy flows through them. And one of the insights that has emerged is that when a system is constantly supplied with energy, it may begin to organize itself in ways that enhance the dissipation of that energy. In simpler terms, if energy keeps flowing into a system, the system may naturally evolve structures that help that energy spread out more effectively. Over time, these structures can become more complex, more efficient, more capable of transforming energy, and at a certain point, something like life begins to appear, not as a sudden creation, but as a gradual refinement, a process shaped by the continuous flow of energy and the tendency to disperse it. You might imagine it like water flowing across a landscape. At first, it moves in simple paths, spreading gently, but over time, channels form, rivers deepen, networks emerge that guide the flow more efficiently. The water is not trying to create these structures, but as they form, they allow the flow to continue more easily, and so they persist. In a similar way, life can be seen as part of this larger process, a network of pathways through which energy flows, transforms, and spreads. And this perspective changes how we think about complexity, because instead of seeing life as something fragile, something that exists in spite of the universe, we begin to see it as something that arises naturally within it, a consequence of the same quiet tendencies we've been exploring all along. Energy flows, possibilities unfold, structures emerge where they help that flow continue, and for a time, those structures persist. There is something deeply calming in this idea that life is not an anomaly, not an interruption in the natural order, but an expression of it, a moment in the ongoing story of energy as it moves, spreads, and explores the vast landscape of what is possible. And yet, this moment is not permanent, because the flow continues, energy continues to spread, and the structures that depend on that flow exist only as long as it persists, which brings us gently back to the source of that energy, to the steady stream that makes all of this possible, the quiet river of low entropy, flowing from the sun to the earth, sustaining everything we see. There is a quiet thread that runs through everything we've explored so far, from the motion of a simple machine, to the flow of heat, to the emergence of life itself. It is always the same idea, unfolding in different forms. Energy arrives, is transformed, and then continues on, more spread out than before. And now, as we step back and look at the Earth as a whole, that same pattern begins to appear on a much larger scale. Because everything we've described, the growth of plants, the movement of animals, the gentle maintenance of life, depends on something constant, a steady flow of energy, and that flow begins with the sun. Every moment the Earth is bathed in sunlight, not as a continuous blur, but as countless tiny packets of energy arriving from across space. They carry warmth, light, and the potential to create change. At first glance, it might seem as though the Earth is simply collecting this energy, storing it, building up more and more over time. But as we noticed earlier, that is not what happens. Over long periods, the Earth releases almost exactly the same amount of energy back into space as it receives. It does not keep accumulating energy. It does not grow endlessly warmer. Instead, it exists in a kind of balance. Energy flows in and energy flows out. And yet, within that balance, something extraordinary is happening. Because the energy that arrives is not the same as the energy that leaves. To see this, imagine once again that you are holding something small but powerful. A few bright, concentrated beams of light. Each one is intense, focused, full of potential. Now imagine that same total amount of light spread out into a soft glow that fills an entire room. Nothing has been added, nothing has been removed, but something has changed. The first is sharp, directed, capable of creating precise effects. The second is gentle, diffuse, harder to gather into something focused, and this is very close to what happens between the sun and the earth. The energy that arrives from the sun is concentrated. It comes in relatively small, intense packets, light that carries a great deal of energy in each individual unit. But as that energy is absorbed, transformed, and eventually released, it leaves in a more spread out form. Instead of a smaller number of intense packets, it becomes a larger number of gentler ones. The total energy remains the same, but the way it is distributed is very different. You might think of it like exchanging a few large coins for many smaller ones. The total value is unchanged, but the form has shifted from something concentrated to something dispersed, and it is this difference, this quiet transformation, that makes everything possible. Because the energy that arrives at Earth is in a form that can be used. It is structured enough, concentrated enough, to drive processes, to warm the surface, to power the growth of plants, to create the conditions for motion, change, and life. But as it is used, it spreads. It becomes part of the wider environment. And when it finally leaves the Earth, it is no longer in that concentrated form. It has softened, diffused, become more evenly shared. Now, imagine if this were not the case. Imagine if the Earth received energy and released it in exactly the same form. No change in structure, no difference in concentration. In that case, there would be no flow, no gradient, no opportunity for energy to move in a directed way. Everything would be in balance, but nothing would happen. No winds, no currents, no life. Because life depends not just on energy, but on the difference between forms of energy, on the ability of energy to move from a more concentrated state to a more spread out one. And Earth, quietly, is a system that makes use of that difference. The sun provides a steady stream of low-entropy energy, energy that is structured, concentrated, and capable of driving change. The Earth absorbs it, transforms it, and releases it again in a higher entropy form. And in the space between those two states, everything unfolds. Plants capture sunlight and turn it into chemical energy. Animals consume that energy and transform it further. The atmosphere moves, the oceans circulate, weather patterns form and dissolve. All of it, part of the same continuous flow. A river of energy, entering in one form and leaving in another. And life exists within that river, not separate from it, but carried by it. There is something quietly beautiful in this picture, that the entire complexity of the Earth, all its systems, all its movement, all its life, depends on a simple imbalance, a difference between how energy arrives and how it leaves. And that difference is not large, it is subtle, but it is enough to sustain everything we know. And as long as that flow continues, as long as the sun provides that steady stream of concentrated energy, the process goes on. Energy arrives, spreads, and continues outward, more diffuse than before. And within that flow, for a time, structure can form, complexity can emerge, life can exist. But this balance, delicate as it is, depends on something even larger, because the sun itself is part of a much greater story. A story that stretches back to the beginning of the universe, where the conditions that allow this flow to exist first came into being. there is a quiet balance that surrounds you at every moment. Not a still balance, not a frozen symmetry, but something far more dynamic. A balance that exists only because things are constantly moving. Energy arriving, energy leaving, structures forming and dissolving all at once. And nowhere is this more clearly seen than in the way life depends on the flow of energy through the earth. Because everything we've described, the growth of a plant, the movement of an animal, even the simple act of breathing, relies on a delicate exchange. Energy must come in and energy must go out, not just in equal amounts, but in different forms. To understand this more deeply, imagine again that steady stream of energy arriving from the sun. It is structured, concentrated, and capable of doing work. It enters the Earth system through sunlight, warming surfaces, driving chemical reactions, powering the growth of living organisms. But what happens next is just as important, because that energy cannot remain in that form. If it did, it would accumulate and the balance would break. Instead, as it moves through the system, it is transformed. Each step spreads it further. A plant absorbs sunlight and stores it as chemical energy. An animal eats the plant using that energy to move, to grow, to maintain its body. At each stage, some energy is released as heat, softly radiating into the air, as motion, interacting with the surroundings, as processes that disperse energy into ever wider pathways. And eventually, all of that energy leaves the Earth, not in the same concentrated form in which it arrived, but as something more diffuse, more evenly distributed, more difficult to gather again. And this continuous transformation, from concentrated to dispersed, is what sustains the entire system. Because life depends not on balance in the sense of stillness, but on balance in the sense of flow, a constant movement through which structure can exist. You might think of it like a stream flowing through a landscape. The water does not stay in one place, it moves continuously. And it is that movement that allows patterns to form, currents, eddies, shapes that appear and disappear over time. If the flow stops, the patterns vanish. The same is true for life. If the flow of low-entropy energy from the sun were to stop, everything would slowly begin to fade. Plants would no longer grow. Animals would lose their source of energy. The structures that define living systems would gradually dissolve, returning to more evenly distributed states, not suddenly, but gently, over time. Because without the input of concentrated energy, there is nothing to sustain the delicate balance that life requires. And this reveals something important. Life is not maintained by resisting entropy. It is maintained by participating in its increase, in a controlled and organized way. Energy enters in a structured form and leaves in a more dispersed form, and in between, for a brief moment, structure can exist, complexity can arise. Now imagine what would happen if the Earth were a closed system, if no energy entered and none left. At first, everything might continue as before, but gradually, the differences that drive processes would fade, temperatures would even out, energy would become uniformly distributed, and without those differences, there would be no movement, no flow, no life. Everything would settle into a quiet equilibrium, a state where nothing changes, because everything is the same. But Earth is not a closed system. It is open, connected, part of a larger flow that begins with the sun and extends outward into space. And it is this openness, this connection, that makes life possible, because it allows energy to pass through, to be transformed, to create temporary structures before continuing on. And this idea extends beyond Earth. It applies to any system where energy flows, where there is a source and a sink, where something enters in a concentrated form and leaves more spread out. In such systems, there is always the possibility for structure to arise, for patterns to form, for complexity to exist, for a time, but always within limits, always dependent on the continuation of the flow. And this brings us back to a deeper perspective, that what we see around us, life, movement, complexity, is not a permanent state. It is a process, a moment in an ongoing transformation, energy arriving, energy spreading, structures forming and dissolving in a continuous cycle. And there is something quietly humbling in that everything we know, everything we experience, depends on a delicate imbalance, a difference between what comes in and how it leaves, a difference that allows energy to move, and in moving, to create the conditions for life. But this flow, as steady as it may seem, has a beginning, because the sun itself, the source of this low entropy energy, is not eternal. It is part of a larger story, a story that begins with a universe in a very special state, one that made all of this possible. There is a quiet question that lingers. Once you begin to follow entropy all the way outward, if everything we see, life, motion, structure, depends on energy flowing from a more concentrated state to a more spread out one, then where did that initial concentration come from? Where did the universe find its starting point? Because if entropy is always increasing, if systems move from less likely arrangements to more likely ones, then, in the past, things must have been different, more structured, more specific, less spread out. And if you continue tracing that idea backward, further and further, you arrive at a moment unlike any other, the beginning of the universe, what we often call the Big Bang. Now, when people imagine the early universe, they often picture something chaotic, explosive, wildly disordered, a kind of cosmic turbulence. But the reality is much more subtle. In fact, the early universe was remarkably smooth. Matter was spread out almost perfectly evenly. The temperature was nearly the same everywhere. There were no stars, no galaxies, no clusters of matter, just a vast uniform sea, gently expanding. And at first glance, this might seem like a state of high entropy. After all, everything is already spread out. Isn't that what entropy tends toward? But here, something unexpected appears, because when gravity enters the picture, our intuition begins to shift. Gravity is different from most forces we encounter. Instead of pushing things apart, it pulls them together. It encourages matter to clump, to gather, to form structures. And this changes how we think about what counts as spread out or mixed. Without gravity, a uniform distribution of matter would indeed represent a high entropy state, everything evenly dispersed, nothing left to change. But with gravity, that same uniform state becomes something very different. It becomes highly unlikely, because gravity allows for many more possible arrangements where matter is unevenly distributed, where it forms clumps, clusters and structures, galaxies, stars, planets. All of these represent ways for matter to be arranged, and there are vastly more ways for matter to be clumped than perfectly uniform. So, in a universe governed by gravity, a smooth, evenly distributed state is not the most likely outcome. It is one of the least likely, which means it is a state of low entropy. This is the quiet paradox. The early universe looked simple, but it was actually very special, very specific, very unlikely. And it is precisely because it began in this low entropy state that everything else became possible. As the universe expanded, small variations began to grow. Tiny differences in density, barely noticeable at first, were amplified by gravity. Matter began to gather, clouds formed, stars ignited, galaxies emerged, and in each of these processes, energy was transformed. Potential energy, the energy stored in the position of matter within gravitational fields, was converted into motion, into heat, into radiation. And as that happened, entropy increased. The universe moved from its smooth, unlikely beginning into a more structured but also more probable state. A state where matter is distributed in countless different ways, forming the complex patterns we observe today. And this idea, that the universe began in a very low entropy state, is sometimes called the past hypothesis. Not because we fully understand why it happened, but because it appears to be necessary. If the universe had begun in a high entropy state, everything would already be evenly distributed. There would be no gradients, no differences, no flows of energy, no stars, no planets, no life, just a quiet, unchanging equilibrium. But instead, we find ourselves in a universe full of structure, full of movement, full of ongoing change, and that is only possible because of where it began. There is something quietly profound in this realization that everything we see, everything we experience, depends on a condition set at the very beginning, a universe that started not in randomness, but in an extraordinarily ordered state, and yet we do not know why. We can describe it, we can observe its consequences, but the reason behind it remains one of the deepest open questions in physics. Still, even without that answer, we can follow what happened next. Because once the universe began in that low entropy state, the direction was set, not by a force, but by probability. From that rare, specific beginning, the system began to explore more common arrangements, more possible configurations, more ways for matter and energy to be distributed, and doing so, it created everything we know: stars burning in distant galaxies, planets forming from clouds of dust, life emerging on at least one small world, all of it part of the same unfolding process, a journey from the unlikely to the likely, from the simple to the complex, and eventually back towards simplicity again. Because as entropy continues to increase, the differences that allow structure to exist begin to fade. Energy spreads further, gradients weaken, the flow that sustains complexity slows, and this leads us gently to the final stage of the story, a future where the universe reaches its most probable state, a state where energy is so evenly distributed that nothing more can happen, no motion, no change, no direction. But before we reach that stillness, there is one more piece to understand, because along the way, the universe has created something unexpected, something that gathers enormous amounts of entropy into a form that seems almost paradoxical: black holes. As the story stretches outward, from the quiet balance of Earth to the vast unfolding of the universe, everything begins to settle into a single continuous arc, a beginning, in a rare and delicate state, a long unfolding, full of structure, motion, and change, and a gradual movement towards something softer, quieter, more evenly spread. Along this path, one of the most surprising chapters emerges, a place where entropy does not simply increase gently, but gathers in a way that feels almost extreme: black holes. They're often imagined as mysterious, consuming objects, regions of space where gravity becomes so strong that nothing can escape. Light falls inward, matter collapses, everything that crosses a certain boundary, is lost to the outside world. But beyond their dramatic appearance, black holes reveal something deeper. They are not just objects of gravity, they are also vast reservoirs of entropy. At first, this might seem strange. If entropy is associated with spreading out, with energy becoming more evenly distributed, then why would something so compact, so concentrated, contain so much of it? The answer lies in how we measure what is possible. Earlier we saw that entropy is not just about appearance, but about how many ways a system can be arranged. And for black holes, the number of possible internal configurations is enormous, far beyond anything we encounter in ordinary systems. Even though a black hole appears simple from the outside, defined only by its mass, its rotation, its size, it hides an extraordinary number of possible micro-level arrangements within, so many that it becomes one of the highest entropy objects we know. This idea was developed through the work of scientists like Stephen Hawking, who showed that black holes are not entirely silent. They emit a faint form of energy, a slow, gentle radiation. Over immense stretches of time, this radiation allows them to gradually lose mass, to fade, to disappear, and as they do, the entropy they contain is released back into the universe, not in a sudden burst, but as a quiet continuation of the same process we've been following all along, energy spreading, possibilities unfolding. Now, step back for a moment and take in the larger picture. The universe began in a low entropy state, smooth, uniform, full of potential. Over time, gravity shaped that simplicity into structure. Stars formed, burning brightly as they transformed energy. Galaxies emerged, vast systems of motion and interaction. Life appeared, briefly, in certain places, using the flow of energy to create moments of complexity. And along the way, black holes gathered enormous amounts of entropy, becoming central players in the cosmic story. But throughout all of this, one thing remained constant. Entropy increased, not quickly, not dramatically, but steadily. And as it continues to increase, the differences that allow structure to exist begin to fade. Stars exhaust their fuel and slowly dim. Galaxies drift apart, carried by the expansion of space. The energy that once flowed in concentrated streams becomes more evenly distributed. Temperatures even out, gradients weaken, and the processes that once drove motion begin to slow. This leads to a state often described as the heat death of the universe, not an explosion, not a collapse, but a gentle stillness. A condition where energy is so evenly spread that no further change can occur, no flow, no movement, no structure forming or dissolving, just a vast, quiet equilibrium. And in that state, something subtle disappears, the arrow of time, because without change, without the movement from less likely to more likely states, there is no direction, no unfolding, no distinction between before and after. Time, as we experience it, loses its meaning. But before reaching that stillness, there is a long, slow transition, a fading rather than an ending. And within that fading, you can see something quietly profound. Because the universe begins in simplicity and ends in simplicity. At the beginning, everything is smooth, uniform, highly ordered. At the end, everything is evenly spread, fully dispersed. Both states are simple, and yet, between them, there is a narrow window, a brief, delicate phase where complexity can exist, where patterns form, where structures emerge, where life appears and becomes aware of itself. You might picture it like a drop of cream swirling into coffee. At first, the cream is separate, distinct. At the end, Everything is mixed into a uniform shade, but in between, there is motion, swirling patterns, fleeting structures, moments of beauty that arise and then gently fade. And that is where we are, not at the beginning and not at the end, but in that middle space, a moment in the larger flow, a brief pause where the universe becomes complex enough to observe itself, to ask questions, to wonder about its own nature, and perhaps in that sense, entropy is not just a measure of spreading. It is also the reason anything interesting ever happens at all. Because without that movement, without that gentle drift from one state to another, there would be no change, no patterns, no life, only stillness. And so, as the story comes to rest, there is something quietly comforting in this perspective, that everything we see, everything we experience, is part of a natural unfolding, a process that began long before us and will continue long after. And within that process, for a brief moment, there is awareness, there is curiosity, there is the quiet act of understanding.